In this video, we're going to try to show that this series is either convergent or divergent. Our main aim here is to apply the integral test. So first, we can see that this series given by its general term, which is 1 over 2n squared plus 3n plus 1, is positive. It's also decreasing, because if we try to compute an plus 1 minus an, we'll see that we have something less than 0. Okay? And this one can be transformed to the integral test if we can define an as f of n. So our function in this case, f of x, is going to be 1 over 2x squared plus 3x plus 1. And we see that f is positive, decreasing, and continuous on this interval 1 plus infinity. Okay, therefore it satisfies the conditions for the integral test. All we need to do is to show if this integral, let's say 1 plus infinity f of x dx, which is 1 plus infinity 1 over 2x squared plus 3x plus 1 dx, if it is convergent or divergent. First, note that we can rewrite this one, 2x squared plus 3x plus 1, as 2x squared plus 2x plus x plus 1, and we can factor by 2x to get 2x times x plus 1 plus x plus 1, and therefore we get x plus 1 times 2x plus 1. Okay? All of them are defined on this interval 1 plus infinity. Okay, therefore we can decompose this one in fractions. So we can rewrite 1 over 2x squared plus 3x plus 1 as a over x plus 1 plus b over 2x plus 1. We can collect alike terms. So here we have 2a plus b times x plus a plus b over x plus 1 times 2x plus 1. Therefore, from here, we see here there is no x. Therefore, we have a plus b, 2a plus b is 0, and a plus b is 1. Okay? So we solve, we have b is minus 2a, and if we solve here, we get a is minus 1, and b is 2. Therefore, we have this one written as minus 1 over x plus 1 plus 2 over 2x plus 1. Therefore, we can integrate 1 plus infinity 1 over x squared 2x squared 3x plus 1 dx as in here. Okay? But from here we know that this one is given as the limit as t goes to infinity of this one is just minus the natural log of x plus 1, okay, plus the natural log of 2x plus 1 between 1 and x and t. Okay. So plug in the t, we get the limit as t goes to infinity of ln of 2t plus 1 minus ln of t plus 1. When we plug the 1, so we have minus, with the minus it's going to be ln of 2 minus ln of 3. Okay? And this one would let us change when we use the rules of the natural log, so we have ln of 2t plus 1 over t plus 1 plus natural log of 2 over 3. Okay, so this is a constant, and once we take limit inside, because this one is continuous, we get the limit of 2t plus 1 over t plus 1 as t goes to infinity is 2. So therefore we have the natural log of 2 plus the natural log of 2 over 3. Okay, and this is we can also simplify this one as the natural log of 4 over 3. Okay, so this one is finite. Okay, so therefore this one means that our integral is convergent, and therefore our series is convergent as well. That means this series, it has a finite sum. Okay, according to the conditions and to the application of the integral test for series. I hope that I didn't make any mistakes here. Let's check one more time. When t is x, we have 2x, 2t plus 1 over t minus 1. And when we have minus 1 and 2 minus 3, that's 2 over 3. And when we have the limits, that's 2, it's 2, that's it. Yes, I think that's right. Thank you.